Hey everybody, this is Mr. Beckstrom, and today I want to do an example. This is number 12 from section 9.1 on matrices. And here we're going to solve a system of equation using Gaussian elimination. And then we're going to state whether the system is independent, dependent, or inconsistent. So let me tell you what each three of these mean. Independent means that I have exactly one answer for each of my variables. So for example, like x equals 2 and y equals 1 would be an independent system. A dependent system is when I have an infinite number of solutions. And that happens when these actually end up being the same line. So if these end up being these two lines here, because these are both lines just in standard form, if these end up being the same line, then they have an infinite number of points that are in common with each other. So there's an infinite number of solutions. And then the last one is an inconsistent set, and that's where there are no solutions. That would be if these were two lines that were parallel, but they never intersected. Remember, independent would mean that they intersected at one point. Inconsistent means that they're parallel and these two lines never connect. And dependent means that they're right on top of each other, so they have an infinite number of points in common. All right, so that's my three possibilities there. Now, as far as Gaussian elimination goes, what we're going to do is first we're going to turn this into an augmented matrix. So let's do that. That's a pretty easy part here. All we're worried about is the coefficients, the values in front of the variables. So if we do a matrix, so on here the coefficients are -10, -3, and then I'll put makes it an augmented matrix where the equal signs are, and I'll put a -37. Down here, I'm just going to put a 4, a 1, and a 15. All right. Now, what I want to do is I want to solve for both x and y. And I can do that by using these row operations. And these are the same kind of things that I can do to normal equations, right? I could normally multiply an equation through by a number. I could switch these two equations around. I could put the bottom one on top and the top one on the bottom. And actually, I can do one other thing that we don't usually do a lot, but we can do it, and that is, well, do a lot, probably haven't seen it that much, but we can take a multiple of one equation, so I can multiply this first line by like 3, and then I could add that to the second equation. And that's just really kind of combining two steps in one, right? It's multiplying an equation by this, and then it is adding one equation to another equation, or subtracting. So these are the three things that I can do. And when it's in augmented form here, I have a goal. And my goal is that I want this value here to be a 1 in the upper left corner, and this value here to be a 0. Because if this is a 1 and this is a 0, and I were to put this back into regular form, that would be 1 times x minus 0 times y. So that would just give me x is equal to some value over here, and that's basically solving for x. And I want to kind of do the same thing for the y's. For the second equation, I want to put a 0 here and a 1 there, because if it is 0x plus 1y, that's the same thing as y is equal to, and it'll give us some value over here. So I'm going to kind of write it below, but what I want to end up getting is 1, 0, 0, 1, and then these values over here will be this will be my x, and this one will be my y, right? So this is what I'm trying to get. This is called an identity matrix, the 1, 0, 0, 1. An identity matrix is a matrix with ones down the diagonal from upper left to lower right. It's a square matrix, so it has to be, like, for example, this is a 2 by 2 here. Or it could do a 3 by 3. So it would be the ones go down the diagonal, and you have zeros in every other position. and that's called the identity matrix. Let me show you what one looks like for a 3 by 3. It would just be like this: 1, 1, 1, 1 down the middles, and then 0 in every other position. And we're going to need to know how to do 3 by 3s soon. And this would solve for like an x, a y, and a z, or some third variable. All right. So let's use these row operations and this terminology in order to solve this problem here. So I'm going to start over here, and with -10, -3, 4, 1, and then I have the augmented matrix, and I have -37, and I also have 15. All right. So let's take a look at how I can get this first position here to be a 1. Now I could divide through, remember dividing is really the same thing as multiplying, or multiplying by -1/10, right? Or dividing by -10. This entire row, that would give me a +1 here, but it'd give me a fraction here and a fraction there. So if I can avoid getting a fraction, and that would, if I can avoid getting a fraction, I would do that. And that's really using the number 2 here, multiplying every entry in a row by the same non-zero real number. So you could do that. What I could also do is I could take a multiple of this row down here, and I could try to get a 1 here, but these two numbers aren't relatively prime, right? So there's no multiple of 4, like 8, that I could add to this to get a +1, because it goes from like -2 to +2. So I can't really do that either. So I'm thinking with this problem here, I'm going to end up needing to do some kind of fraction. But in the meantime, what I'm going to go ahead and do is I'm going to flip those two rows. So this is just to get the 4 on the top. That'll make these fractions not as bad. So that says I'm going to flip row 1, or exchange row 1 with row 2. All right. And this gives me 4, 1, -37, and -10, -3. Oh, this should be 15. We have to do the entire row, and this will be -37 down here. All right. So let's keep going. Now I'm going to go ahead and divide by 4, or multiply by 1/4 that first row to get a 1 there. It's going to give me a couple of fractions, but I think I'm going to end up using my calculator to help me with this. So we can deal with fractions. So I'm going to do 1/4 times row 1, and that's going to give me my new row 1. And that's how I write that. So 1/4 times row 1 gives me my new row 1. So on my next matrix, row 2 stays the same. So I'm not messing with row 2. So go ahead and just leave that how it is, and -37. And then I'm going to multiply row 1 by 1/4, or divide by 4. So I get a 1 there. That's what I want. I get a 1/4 here. And I get a 15/4 here. 15/4. All right. Now that I have my 1 here, I want to finish my column before I move to the next column. So the only way to get a 0 down here would be to multiply this row here by a -10, right? Because that would make a -10, and add it to this row. So that's what I'm going to do. I'm going to do -10. Oh, excuse me, not -10, +10, right? Because a 10 plus a -10 is 0. So +10 times row 1 plus row 2 plus row 2, and that's going to give me my new row 2. All right, now here's where I'm going to end up using my calculator. So I'm going to go ahead and start off. I'm not messing with row 1. Remember, I'm only messing with what's on the right side of these little things here, right? So row 1's going to stay the same. So that's going to be 1/4, 15/4. And this next row here, I'm going to take 10 times this and add it to this. So let's go ahead and use my calculator. And this is what I'm going to do. So I'm just going to do 10 times row 1. So this entry here, 1, plus this value here, -10. And that gives me my new row 2. So that first one is a 0. And of course it's going to be a 0 because that's why I picked 10 in order to 0 it out. But now I've got to do it with everything else. So the next one is going to be 1/4 times 10, because we have to multiply the entire row 1 by 10 and add it to this row. So 1/4 times 10 plus -3. -3. Oh, I think I left the 10 out of there. 10 plus a -3. All right. And that's going to give me, and we'll put that in fraction form, -1/2. So I have a -1/2 here. And I'm going to do the same thing on the last one. So 10 times row 1. So 10 times, doesn't matter what you do the multiplication in, it's commutative. 10 times 15/4. Make sure you put your fraction in parentheses. Plus -37. -37. And that's going to give me +1/2. All right. And I'm going to kind of go up to here. So keep it all here. All right, so here's my new thing. So I finished my first column. I have the 1 and then the 0. Now remember, this next column has to be a 0 and then a 1. And when we start the new column, we are always going to start by making this position here on the diagonal a 1. So how do I get a 1 from a -1/2? Well, I can just multiply it by -2, right? If you want to solve a little equation on the side, you can say, what times -1/2 gives me 1, right? And then you could solve that equation there. You multiply both sides by a -2, and -2 cancels out, and you're just left with x equals -2. So that's the value that I need to multiply this row 2 by in order to get a +1 here. So I'm going to do -2 times row 2 gives me my new row 2. All right, so this is a long process, but row 1 stays the same right now. We're not messing with that. Notice we're only messing with row 2. 15/4. And down here, we're going to multiply everything by -2. Well, 0 times -2 is 0. Notice that we're not going to be messing with this first column anymore. If you do anything that changes this first column from the 1, 0, then you did it wrong. Once you get that first column done, you shouldn't do anything that changes this first column. All right. And then -2 times -1/2 is 1. And -2 times +1/2 would be -1. All right. Now the last thing that we need to do is get a 0 in this position. So what do we have to multiply this 1 by in order to get a 0 here? Well, it's really just the opposite sign of whatever's here, right? Because 1 times a negative 1/4 would give me a negative 1/4, and a negative 1/4 plus a positive 1/4 would give me the 0. So really, once you get the 1 here and you want to find out what to multiply to 0 this out, just take whatever's there and take the opposite sign. This is a positive 1/4, so we need a negative 1/4. So negative 1/4 times row 2 plus row 1 is going to give me my new row 1. All right. So here I have a 1, 0. That stays the same. The whole bottom is going to stay the same. Negative 1. And the last thing I need to do is multiply this by negative 1/4 and add it, or this by negative 1/4 and add it here. And we already know it's going to give us a 0. That's why we chose negative 1/4. And the last thing we do is do this one here. So let me go ahead and use a calculator for this. And I will say negative 1/4 times negative 1 plus 15/4. Right? Just taking negative 1/4 times this value and adding it to that value. And that's going to give me a positive 4. All right. Now, if we put this back, take it out of the augmented form back into the equation form, this is just going to be 1 times x plus 0 times y is equal to 4. And the second equation will be just 0 times x plus 1 times y is equal to negative 1. And that just means that x is equal to 4 and y is equal to negative 1 once we simplify that. And that is our solution. And lastly, I just want to check it. So 4 and negative 1. Let's use our calculator. So for the first equation, if I do negative 10 times 4 plus negative 3 times negative 1, I should get a negative 37 there. And I do. And for the second equation, if I do 4 times 4 plus negative 1 times the 1 there, basically a 1, I get 15, and that works as well. So those are my solutions using Gaussian elimination. Now, are there more ways to do that? Absolutely. Could we started here and just divided this by negative 10 or multiplied by negative 1/10? Yeah, I think it would have ended up being a little bit harder because then you would have had some kind of pretty crazy fractions. Here we only really had 1/4 and 1/2 by flipping it, but it's just something that you learn after doing these for quite a while. All right, guys. Well, I hope that helped. If you have any questions, please let me know. This is a complicated process at first, but once you get used to it, there's really only 3 different things that you can do to it. You just have to make sure that you're going in the right order. So remember, you start with the 1 on your first column, and then you get the zeros, usually by doing number 3, adding a row, some value times a row to another row to get those zeros. And then you start with the next column. You always start with the position that you want to get the 1 in, and then you do your zeros next. And you just keep going through from column to column until you finish the column, always starting with the position that has the 1 in it. All right, guys. I hope you have a great week. Good luck on the test today, and we'll see you next Monday. Thanks.